What does the remainder of an alternating series look like? It turns out that if you have a convergent alternating series that satisfies the conditions that a sub n plus 1 is less than a sub n, then the absolute value of the remainder in approximating s by s sub n is less than or equal to the first neglected term or the next term that you cut off. So s minus s sub n is going to equal the remainder. Remember, this is our remainder. And that's less than or equal to the value of the next term. And this is, of course, positive. Let's see how we would use this. What if we wanted to approximate the sum of the alternating series? Sum as n goes from 1 to infinity of minus 1 to the n plus 1 divided by 1 over n factorial. Well, this is 1 plus 1 divided by 1 factorial minus 1 over 2 factorial plus 1 over 3 factorial minus 1 over 4 factorial plus 1 over 5 factorial minus 1 over 6 factorial. And I'm tired of writing this, so I'm going to put the next term plus. So what if, well, first of all, I need to check. Does it converge by the alternating series test? Is 1 over n plus 1 factorial less than or equal to 1 over n factorial? Well, yes, this is true. You have n factorial is less than or equal to n plus 1 factorial. I'm just showing it. So n factorial is less than or equal to n plus 1 times n factorial. So is 1 greater than or equal to n plus 1? And of course, yes, n is positive. So this is true for all n. The next thing we need to do is check the limit as n approaches infinity of 1 over n factorial, and that is indeed 0. So the series does converge by the alternating series test. Now, suppose we want the first 6 terms. What is S6? Well, that's the sum of my first 6 terms, 1, 2, 3, 4, 5, 6. So I'm going to add up these 6 terms right here. All right, so this is 1 minus 1/2 plus 1/6 minus 1 over 24 plus 1 over 20, how about 120 minus 1 over 720. And the exact answer is 91 divided by 144, but I'm going to use a calculator and get that this is about 0.63194. So, what is my remainder? Well, the actual value of the sum minus the 6th term, the 6th partial sum, is equal to the remainder. All right, and this has to be less than or equal to a sub 7. And I really should have, I don't need absolute values because a sub 7 is 1 over 7 factorial. So this is equal to 1 over 7 factorial, or 1 over 5040, which is about 0.0002, if I can read my calculator here. So the sum is somewhere between 0.63194 plus 0.0002 and 0.63194 minus 0.0002. So you can write this as 0.63174 is less than or equal to x. If I've added my numbers correctly.